Hello everyone. Today I'm going to discuss about chemical reactions and equation. So in this chapter, first we should know what is chemical reaction. Chemical reactions are the process in which new substance with new properties are formed. The basic structure of a chemical reaction is like this. There is two parts for a chemical reaction. The left hand side part is called reactant. The right hand side part is called product. Like you can see in this example, magnesium and oxygen reacts with each other to give magnesium oxide. Here, magnesium and oxygen is reactant and magnesium oxide is product. So this is chemical reaction. Basically, today we will discuss about the type of chemical reaction. So, let's come. So, what are the type of chemical reaction? There are five types of chemical reaction we have. What are they? They are combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and oxidation reduction reaction. Today, we will discuss about the first two, that is combination reaction and decomposition reaction. So the first one, which is combination reaction. What do you mean by combination? Combination means when two things are combined. Exactly happens that thing with this chemical reaction. What happens here? Here, two or more than two substances combine with each other to give a single substance. So this is called combination. Substance means they may be element, they may be compound. We have two examples here. In first one you can see that magnesium reacts with oxygen to give MgO, that is magnesium oxide. What is magnesium? A element. What is oxygen? Another one element. So two elements that react with each other to give a compound. And in second case you can see that CaO, that is calcium oxide, reacts with H2O, that is water, to give CaOH whole 2, that is calcium hydroxide. Here calcium oxide and water, they are what? They are compound. So here two compounds react with each other to give another one compound. So this kind of reactions are called combination reaction. Let's come to few more example. The reaction name, what happens here? Elements react with each other. Elements react with each other to give single compound. This thing happens here. Number 1, hydrogen reacts with oxygen to give water. What is the state of hydrogen here? This is in gaseous state. State of oxygen, gaseous state. Water, liquid state. We have to mention about their state. Now we need to know that this is balanced or not. Let's see. This side you can see two hydrogen is there, this side two. But oxygen, there is one oxygen, there is two oxygen. So oxygen is not balanced here. So make it balanced. So put 2 here. If you put 2 here, you can see that right now here is 2 oxygen and 4 hydrogen. But in this side, you can see that there is 2 hydrogen. Then put 2. Now you can see this is that there is 4 hydrogen, 4 hydrogen, 2 oxygen, 2 oxygen. So this is balanced. Now come to our point that here two elements, hydrogen and oxygen, reacts with each other to give one single compound. That is, this is a kind of combination reaction. Come to second. Carbon reacts with oxygen to give carbon dioxide. Carbon in solid state, oxygen in gaseous state, CO2 in gaseous state. Is it balanced? Yeah, of course, one carbon is there, one carbon is there, two oxygen is there, two oxygen is there. So this is a balanced equation, and here also we get the same thing. Two elements react with each other to give a product. Come to another one reaction, that is sodium reacts with chlorine, gives NaCl, that is sodium chloride, a solid, chlorine a gas, sodium a solid. Is it balanced? No, because 2 chlorine is there. Then put 2 here. So here you can see 2 chlorine, but sodium is 1. Then put 2 here also. Now it is balanced. Give another one to make it clear. We want to make FeS. So Fe reacts with sulfur. Iron reacts with sulfur. Sulfur and iron both are in solid state. And what they give? They are giving FeS. That is iron sulfide. That is also in solid state. So here we get 4 example where elements react with each other to give a single compound, which is a kind of combination reaction. Now come to another one kind of combination reaction. Is it clear? Take a snapshot to this, and then we will go to our next part where compounds, two compounds or more than two compounds react with each other to give another one compound. Here also we will get single product, but in reactant side what we have? We have compound. Okay. Let's come to the second, where compounds react with each other to give different product. That is also a compound. So we can write like this: different compound. Let's come to the example. Ammonia, NH3, reacts with what? HCl, and it gives what? NH4Cl. Now what it is? Ammonia reacts with what? Hydrochloric acid, or you can say this is hydrogen chloride, another one name, to give what? To give ammonium chloride. Now what is the state? State is, it is in solid state, HCl is in gaseous state, NH3 is in gaseous state, and this is a balanced equation. You can see here that this one is a compound, this one is another one compound. These two compounds react with each other and it gives another one compound, and this is a single compound, or product is a single compound. So this is also a combination reaction. So we learn about two kind of chemical reaction, two type of combination chemical reaction. There is another one type of combination reaction where compound reacts with element to give a single compound. What happens here? Compound reacts with element to give another one compound, different from this one, different from this compound. So take one example. Carbon monoxide, CO, in gaseous phase react with hydrogen, that is H2, in gaseous phase to give methanol, that is CH3OH, methanol, that is in liquid phase. Here compound carbon monoxide reacts with hydrogen to give another one compound. So this is another kind of reaction. So we here read about three kind of combination reaction. What are they? First one, where elements react with each other. Second, where two different compounds react with each other. And third, where one compound react with one element to give a different compound. So these are the three type of combination reaction. Let's go to the next topic, that is decomposition reaction. So next is what? Next is decomposition reaction. Decomposition reaction is just opposite to composition reaction. So what happens here? In combination reaction, what we can see? In combination reaction, two or more reactant react with each other to give one single product. But decomposition reaction is just opposite. What happens here? Here, let's see the definition. Those reactions in which a compound splits up into two or more simpler substances are known as decomposition reaction. That means what happens here? It is breaking. In combination, you can say that this is joining, and decomposition means it's breaking. Now for decomposition reaction, you need outside source of energy. That source of energy may be heat, that source of energy may be light, that source of energy may be electricity. Now depends on the source of energy, there is different type of decomposition reaction we have. So the first type, that is where the energy is heat, decomposition reaction which require heat. This kind of decomposition reaction is called thermolytic decomposition. What it is called? Thermolytic decomposition or thermolysis. You can see here one example. This is what? This is HgO. This is HgO, mercuric oxide. If you give heat to HgO, what you will get? You will get Hg and O2. That means the reaction is HgO. This one. After decomposition, what you will get? Hg and O2. That is, there is one compound, but it breaks into different product. So this is a kind of decomposition reaction where you need heat energy. Next is another kind of decomposition reaction where you need light energy. If for a decomposition reaction you require what? A light energy, that time this is called photolytic decomposition or photolysis. Like you can see here, in this beaker you have H2O2. What is H2O2? H2O2 is hydrogen peroxide. So in this case, if you keep it in light, which kind of light? Here you can see sun. That means in presence of sunlight, it will decompose, it will break. H2O2 will break. And what it gives? It gives H2O and O2. That is water and oxygen. So for this decomposition, for this breaking, you need what? You need light energy and called photolysis. Now the third kind, decomposition reaction which require electricity. So if for a decomposition reaction you require electricity, this kind of reaction is called electrolytic decomposition or electrolysis. Another one example for this, you can see there is a setup. In this beaker, what we have? We have water and we want to decompose, means we want to break water. So if you break water, what you will get? You will get H2 and O2. So for this you need a setup. You need two electrode which is attached with a battery. One is cathode, another one is anode. When water will break, means decomposition reaction of water in presence of electricity, what we get? We will get H2 and O2 in different electrode. So these are the three type of decomposition reaction. Let's come. We will discuss about few more examples. So discuss about thermal decomposition. Thermal decomposition means what we need? We need heat energy. We need heat energy. We can represent heat like this sign. This is called a delta sign. This one we use for heat. So I'm using this sign here. Okay. So first, decomposition of KClO3. Decomposition of what? KClO3. Name is potassium chlorate, which one is a solid. So if we want to decompose it in presence of which energy? Heat energy. What we get? We get KCl and oxygen. We know that oxygen is a gas, and what is KCl? Potassium chloride. This is potassium chloride, a solid. That means a solid KClO3 breaks in KCl and O2. And what we need? We need heat energy. So this is thermal decomposition. Second type, FeSO4, that is ferrous sulfate, a solid. If it breaks, it gives Fe2O3 plus SO2 plus SO3. What is FeSO4? Ferrous sulfate. What is Fe2O3? Ferric oxide. What is SO2? Sulfur dioxide. What is SO3? Sulfur trioxide. Now, is this two reaction is balanced? Let's check. Here you can see 3 oxygen in reactant side, 2 oxygen in product side. That means no. So make it balance. Put 2 here. If you put 2 here, you can see 2 potassium, 2 chlorine, and 6 oxygen. Now make it same. So if you put 2 in front of KCl and 3 in front of O2, it will be balanced because you have right now 6 oxygen, 2 potassium, 2 chlorine. And for this one, this is also not balanced because 1 Fe and you have here 2 Fe. So make it balanced. So if you want to make it balanced, you can see that you just need 2 Fe this side. If you put 2 here, then automatically it will balance because 2 Fe, 2 Fe, 3, 4, 5, 6, 7, 8 oxygen. 4 2s are 8 oxygen. So this is balanced, and 2 sulfur, 2 sulfur. So these are the two reaction, which is example of thermal decomposition. First one is thermal decomposition. The second one is photolytic decomposition. So for photolytic decomposition, examples are, for this, let's take one example, AgCl. What it is? Silver chloride, which is a solid. In presence of light, it breaks into Ag and chlorine 2 and 2 to make it balance. Take another one example, that is AgBr. Now what it is? Silver bromide. This is also a solid. In presence of light energy, for decomposition reaction, it gives Ag and bromine, that is Br2, which is a gas. Now make it balance, put 2 and 2. This is balanced right now. So this is another one example for photolytic decomposition. So take a snapshot. After that I will erase it. Now come to the third reaction, third kind of decomposition reaction. That is in presence of electricity, which is called electrolytic decomposition. So in the third one, that is electrolytic decomposition, in electrolytic decomposition, what happens? For the decomposition we need electricity. Like Decomposition of NaCl. This is example 1, first example. It breaks in presence of what? In presence of electricity. In presence of electricity. It breaks into sodium and chlorine. Sodium is what? A solid. Chlorine is what? A gas. And NaCl is what? A solid. So what happens here? NaCl breaks into sodium and chlorine. So this is a electrolytic decomposition reaction. Second kind of decomposition reaction, decomposition reaction of Al2O3. What is Al2O3? This is Al2O3. What is Al2O3? This is aluminium oxide. In presence of electricity, it breaks into aluminium and oxygen. So what is Al2O3? Aluminium oxide. It breaks into aluminium and oxygen. Al2O3 is what? This is in molten condition. That means this is not a solid. This is liquid. And what we get? Aluminium in molten condition means when we get the product, this aluminium is also in liquid condition. And in oxygen is obviously gas. So Al2O3 breaks into aluminium and oxygen. This is also not balanced, so make it balanced. So if you want to balance it, put 3 here. If you put 3 here, you can see 6. And here also you have 3 only, so put 2. But if you put 2, aluminium is become 4. So put 4 here. So this is balanced now. So this is the 3 type of decomposition reaction we learned today. That is in presence of heat energy, in presence of light energy, in presence of electricity. What are they? Electrolytic decomposition in presence of electricity, photolytic decomposition in presence of light, and thermal decomposition, that is in presence of heat. So I hope you understand what is this two kind of reaction, that is combination and decomposition reaction. For today, tada.